Okay, so let's go over the imaginary number. What's an imaginary number? The imaginary number I defined to be I equals square root of -1. That is commonly known as the imaginary number. Any real number, multiplied by I is also an imaginary number. Any real number multiplied by I is also an imaginary number. So let's take a look at square root of -25. This is not a real number. Not a real number, but we can write it as an imaginary number. Let's take a look. This is square root of 25 times -1, which is the same as square root of 25 times square root of -1. So this is square root of 25 is 5, and square root of -1 is I. Yes, square root of -25 is not a real number. It's an imaginary number. It's 5I. So we can also write -49. What is square root of -49? That's square root of, you can write -1 first if you like as well, 49. And that is square root of -1 times square root of 49. Square root of -1 is I times square root of 49. That's 7. So I times 7, that's 7I. You may, sometimes there are cases where you can get the, where this doesn't come out completely, like in this case. So this is the same as square root of, I hope you can realize that, you can write it as -1 times square root of 18. See that? So I separated them, but you can do this if you like as well. And that's the same as I. Square root of 18 is 9 times 2. 9 comes out as 3, doesn't it? So this comes out as 3, so I times 3 square root of 2. So the way we write it, I times 3 is the same as 3I square root of 2. Now, I advise you, whenever you have I and you have a square root, a radical, write the I before the radical. But if it comes out completely, write I after the number, like 5I, 7I. But if you have a radical, make sure you write the I before the radical. Sometimes students tend, if they write it after the radical, sometimes students tend to write it inside the radical. Okay? So a complex number can be written as z equal a plus bi. Okay, well, a is the real part and b is the imaginary part. So an example of a complex number would be 3 plus 2I, where 3 is a real part, 2 is the imaginary part. Another example, -1/2 minus 7I. This is an imaginary number as well. A and B are real numbers. They can be decimal, they can be fraction, they can be a whole number, right? So this is an example of an imaginary number. 2 minus 3I as well. This is also an imaginary number, -1/3 I. I don't have the real part, but this is still a complex number. Okay? Sometimes this is called pure imaginary number. It doesn't have a real part. All right? And also 7 is also an imaginary number. 7 is the same as 7 plus 0I, isn't it? Remember, b is a real number. It can be 0. So real numbers are also complex numbers. Okay? Now, how do we add two complex numbers? Let's go ahead and do that. So 2 plus 5i plus 3 plus 7i. How do you add them? Well, you simply add the real parts together and the imaginary part together. So let's see. 2 plus 3 is 5. 5 plus 7 is 12i. So you add the real parts together and the imaginary part together. Okay, and if you have here real part together, imaginary part together, -3, -6 is adding them together. So this is 1, this is 2. -3, -6 is -9. -2i plus I is -1i or -i. Okay? So this is what you do. Sometimes you add complex numbers and the second part is only imaginary part, is only pure imaginary number. No problem. We combine these two together. This gives me what? 10. -5i plus 6i is plus 1i or I. So you can think about it as 6 minus 5 is 1i, that's I. Alright? You can also subtract. So let's go ahead and do this. Subtract. So 2 plus 3i minus 7 minus 2i. How do we do this? Well, so you can do this in a couple of ways. So you can do 2 minus 7, that's the real part, right? Plus 3i minus 2i. So what does that give you? 2 minus 7 is -5. So this will gives me what? 3i plus 2i, doesn't it? Negative times negative plus 2i. So that gives me -5 plus 5i. You could have, if you wanted to, also distribute the negative. What would that give you? 2 plus 3i, get rid of the parentheses, -7, negative times negative, that's plus 2i. So 2 minus 7, combine the real parts together, is -5, plus 3i plus 2i is plus 5i. You could have also done that also here while you're adding as well. Just get rid of the parentheses. So, you know, and then add the real part together and the imaginary part together. So it's as simple as that. You just add them like this. Now let's go ahead and multiply complex numbers. So what do? Let me give you several examples. 2i times 7 plus 3i. Here I'm multiplying a pure imaginary number by a number that have a real part. No problem. You just use distributive property. Same as we've done before. 2i times 7, that's what? That's 14i. 2 times 7, 14i. 2i times 3i, you multiply the numbers together. 2 times 3 is 6. I times I is I square. Now let me go ahead and talk to you what is I square. I square is I. I we already know is what? We already know that I is square root of -1. So that's the same as saying -1 squared. What's -1 squared? The square cancels the square root, and what's left? -1. So always remember I square is -1. So that's the same as 14i plus 6 times -1. And what does that give you? 14i minus 6. writing it as a complex number, a plus bi. Let's write this one first. Negative 6 plus 14i, and we just multiplied. So this is separate on the side. Okay, so when you add and subtract complex numbers, you get a complex number, just like we did earlier. When you multiply complex number, you also get a complex number. Now, how would you multiply this? You use the distributive property, and you're also going to get a complex number. So 3 times 9 is 27. 3 times 5 is 15i. Negative 7i times 9 is negative 9 times 7, 63i. Negative 7i times 5i, negative 7 times 5 is negative 35. I times I is I squared. Now, combining like terms, remember we have like terms here. We just combine them. And remember, we let I square equal to negative 1. So always remember, I square is equal to negative 1. Okay? So now let's go ahead and simplify. Let's combine these. These are like terms. They have both I, so let's combine them. 27. 15 minus 63, if you plug it in the calculator, you get negative 48i, right? So these are like terms, as you call it. They both have I. You combine the coefficients. And here you have negative 35 times negative 1, right? So you have what? 27 minus 48i. Negative 35 times negative 1 is positive 35. Now combining the real parts together was 27 plus 35. What does that give you? It gives you 62 minus 48i. And that is your complex number. So exactly the way you learn, you use the distributive property, except now here I square is I. So it's really simple, as you see. Multiplying. So that's the last thing I want to talk about, division. Or actually, I'll write one more thing. Divide complex numbers. So let's see, 2 over 7 minus 2i. Divide and write it in the form a plus bi. How do I do that? With the denominator 7 minus 2i. Well, let's take a look. What's the conjugate of 7 minus 2i? So the conjugate of 7 minus 2i is 7 plus 2i. So it'll be the same, but the sign is opposite. Okay? And then the conjugate, so what happens if I multiply them together? So if I multiply the conjugates together, what does that give me? You can, if you want to, you use a distributive property. 7 times 7 is 49. 7 times 2i is 14i. Minus 2i plus 7 is minus 14i. Minus 2i times 2i is minus 4i squared. The 14i and the negative 14i cancel each other, and you are left with 49 minus 4i squared. Remember, I squared is negative 1. So 49, negative times negative plus 4, which is what? 53. If you notice, when I multiply them, I no longer have I. Whenever you multiply conjugates, you always get that. You get rid of the I part. So this is going to help us in getting rid of the I in the denominator, because we want to write it in that form. Okay? So let's go ahead and do this. Let's use our example. 2 over 7 minus 2i. 2 over 7 minus 2i. Let's divide it and write it in the form a plus bi. So how do I do this? If I multiply by the conjugate, the denominator, whatever I multiply by the denominator, I have to multiply by the numerator. Remember that? 7 minus 2i times 7 plus 2i. I just multiply them. What did I get? I got 53. And that will be in the denominator. This times this, it's in the denominator 53. And then you can leave this 2 times 7 plus 2i, but we want to write it in the form of a plus bi. So we need to distribute 2 times 7 is 14. 2 times 2 is 4i divided by 53. Let's write it in complex a plus bi. So you separate them, 14 over 53 plus 4 over 53i. This is the way you divide complex numbers. You have to multiply by the conjugates of the denominator. Now I multiply them. What did I do just now? I use the distributive property, but you don't have to. Remember, you have a minus b times a plus b. Remember what that is? A minus b times a plus b. That's a squared minus b squared. You can remember to do that. A squared minus b squared. A, that's 7 squared, minus b squared, 2i squared. So it's 49 minus 4i squared, right? And we all know that I squared is -1, so that's 49 plus 4, which is 53. You may guess it to do it right away like that. So whenever you multiply conjugates, you always get rid of the I in the denominator, and that's what I want. I just want a number in the denominator. So let's do one more problem. Divide -7 divided by 2 plus 3i. Now, what is the conjugate of 2 plus 3i? Remember, these would be the same. The only thing is the opposite sign in the middle. So the conjugate of 2 plus 3i is 2 minus 3i. Remember that? So you multiply here by the conjugate. Why do I multiply by the conjugate again? So we can get rid of the I in the denominator. So 2 plus 3i times 2 minus 3i. Again, this is a minus b times a plus b. Or a plus b times a minus b. So a, b. So that's a square. That's 2 square. You may want to write it 2 square, or you may want to directly write it as 4. Minus b square. B square is 9i square. See how simple it is? So this is a square and this is b square. So remember, a minus b times a plus b is equal to a square minus b square, or you can write the a plus b first. So remember, you're going to be using this here to get rid of the I in the denominator when you divide complex numbers. So that's, b squared. That's 9i squared, sorry, or 9i squared. So that gives us 4 minus 9 times -1, which is 4 plus 9. You may recognize this as -1, negative times a negative, that's positive. So you may write it right away like that, like plus 9. 9 plus 4 is 13. So the denominator immediately becomes 13. I just multiply them on the side. And here I have -7 times this. So -7 times 2 minus 3i. Distribute, there's nothing to simplify. By the way, you try to simplify. -7 times 2 is -14, plus 7 times 3, 21 over I. I over 13, and you can separate them. Negative 14 over 13 plus 21 over 13i. So this is in the form of a plus bi. By the way, nothing's simplified in this example or in the previous examples. A lot of times they do. You just simplify. So if that had been a 7, 21 divided by 7, you would write at 3i. So you simplify. So this is complex numbers, right? One thing I want to give you here, I showed you these examples right here. But sometimes you may multiply with numbers like this, like negative 25 times square root of negative 36. Please, please, do not multiply like this, because what happens then, the negative time negative becomes positive, so you multiply 25 times 36. Write it down. This is what wrong. Okay, what is this? You write this as 5i. We just got it right. It's 5i. So you can think about it. Square root of 5 is 5. Square root of negative 1 is I. Times square root of 36 is 6. Square root of negative 1 is I. And now you multiply them together. Don't do this. Not when it comes to the complex. Not when it comes to the imaginary number. So 5i times 6i gives me what? 5 times 6 is 30i squared. That's 30 times negative 1. Remember, I squared is negative 1. That's negative 30. Okay, so make sure you break them up like this. Okay, so how would you multiply square root of negative 8 times square root of negative 2? Let's see. This gives me what? Let's see. I can write it as square root of 8i, right? So I square root of 8 times here I square root of 2, right? Simplify. So 8 becomes what? Is 4 times 2 times I square root of 2. The 2 comes out. So what does that give me? The 4 comes out as 2, so 2i square root of 2 times I square root of 2. So let's go ahead and multiply them. Worked out nicely. 2i and I. So 2i times I is I square. Square root of 2 times square root of 2. What's square root of 2 times square root of 2? The square root of 2 square. So the square cancels the square root and the 2 comes out. I square becomes negative 1. And the 2 here. So 2 times negative 1 times 2, that's 4 times negative 1, negative 4. And I'm going to stop here.